vectors in 3D, our first lesson is focusing on the magnitude of a given vector, the direction ratios of that vector, and the direction cosines of the vector. If A is the point A, B, C, then the position vector representing this point is given as OA equal to AI plus BJ plus CK. This vector has magnitude m, magnitude of this equal to the square root of A squared plus B squared plus C squared. So for any given vector, this is how you find its magnitude. Also, the direction ratios of the vector OA are simply the scalar components of these vectors. That is, A is to B is to C. This gives us the direction ratio. So if you are asked to find the direction ratios, you simply take the scalar components of the vector. And then for the direction cosines, we have this A divided by the magnitude of the vector and B divided by the magnitude of the vector and finally C all over. That means each component divided by the magnitude of the vector gives us the direction cosines. What you should also note is that this direction cosines represent the cosines of the angles that this vector makes with the respective OX, OY, and OZ axis. That is, if theta is the angle that this vector makes with the OX axis, and beta is the angle that this vector makes with the OY axis, and alpha is the angle that the vector makes with the OZ axis, then we are saying that cos theta is this. That means this direction cosine. And cos beta is this. B on the magnitude of OE. And finally, cos alpha is equal to C on this. With this, you are able to find the angle that the vector makes with any of the axes simply by taking the cos inverse of both sides. So if we are looking for theta, which is the angle that the vector OA makes with the OX direction, then we simply take theta is equal to the cos inverse of this stuff here, we get it. If we are looking for the angle that it makes with the OY axis, we take the cosine inverse of both sides. So we get beta as the cos inverse of this thing, and same thing applies for the angle it makes in the OZ direction. Let us see an example that exemplifies these cases. This example wants us to find the direction ratios of the vector CB and the angle that CB makes with the OX axis, given that OB is this and OC is this. We know that CB, first of all, is what? Is defined as OB minus OC. So substituting OB here and OC here, we simplify to get OCB as we have 2i minus 3j plus 6k minus OC. OC is 2i minus j plus 2k. Simplifying this gives us 2 minus 2i, which is 0i. Then we have negative 3j minus O plus j gives us negative 2j. And then we have 6k minus that, it gives us 4k. So this is the vector CB. With this vector CB, we see that the direction ratios are what? The direction ratios are, we have 0, for I, -2 for J, and 4 for K, like that. Then the second part wants us to find the angle that CB makes with the OX axis. To find that angle is the cosine of OD. We have the cosine. If theta is the angle, then we have that cos theta is equal to what? The direction ratio, the component in the OX direction, which is 0, divided by the magnitude of our CB. But now, 0 divided by this is just 0. Therefore, we are saying that this angle is equal to the cos inverse of 0, which is what? 90 degrees. So, the vector CB is perpendicular to the line or to the x-axis since its angle is 90 degrees. This is how you solve this kind of problems. Thank you.